Hello pre-calculus students, and welcome to a video that's going to review some of the parent function transformations. Now first of all, before I start with the transformations, I just want to remind you to review page 122 in your textbook or any resource that you may have that goes over the parent functions that we have that we're going to be covering in this class right now. Okay, we're adding on to these later, but for now it's expected that you refresh your memory, come back to these and know how to apply transformations of them, all except for the greatest integer function. The greatest integer function we will talk about separately, so don't worry too much about that one. But you should definitely know constant identity square function, which is parabolas, the cube, square root, and cube root functions, and then the reciprocal and absolute value functions. Okay, so what we're going to do is we're going to talk, first we're going to talk about the transformation y equals f of x minus h. And so we're going to do that with the parent function square root of x. So let's just quickly graph the square root of x. Let's plot some points. Now I used u and square root of u. You'll see why in a minute, but I'm just using this right now for some points. So we can put 0 in here, and the square root of 0 is 0. So we can plot the point 0, 0. We can put 1 in here because the square root of 1 is 1, and plot the point 1, 1. And then we put 4, because it's a perfect square and we're dealing with radicals, it's nice to skip to 4 because the square root of 4 is a nice even 2, so that we can plot the point 4, 2. So there is the graph y equals f of x. Okay. Now let's look at another function, y equals square root of x plus 4. Now this is going to involve a horizontal transformation, but I kind of want to try to get you a little bit of a feel for why that happens, because when we get more involved with the inner function, the stuff that's happening on the inside of the radical is the inner function, it's going to help us to have a little bit more of a method than we had before. So what we're going to do is we're going to take, now we've got this u t-chart, and I'm going to show you why we have it. We're going to take the radicand and make that u. So we're going to say u equals, let's just do that in blue, u equals x plus 4. Now that means that x equals u minus 4, which means that to get to the x's here, we're going to have to subtract 4 from the u's here. So let's go ahead and do that. So we have 0 minus 4 is negative 4. 1 minus 4 is negative 3, and 4 minus 4 is 0. Now nothing's changing on the outside of this function, so nothing's changing with the y's, so they're still going to be 0, 1, 2. So now let's plot those 3 points. So we have negative 4, 0, negative 3, 1, and 0, 2. 0, 2 right there. And there is the same, a little sloppy there, but that's the same function moved over to the left 4 units. And notice what happened here was when we added the 4 inside the radical, we moved it to the left, which is, you can kind of think, counterintuitive in a way because it's a negative direction. Okay, let's do the same thing with our last graphs, y equals square root of x minus 1. So this time we're going to let u equal x minus 1, which means that x is equal to u plus 1. So we're going to take all of the u's in here and add 1. So 0 plus 1 is 1, 1 plus 1 is 2, 4 plus 1 is 5, and again nothing happens to the y values, so there's still 0, 1, and 2. We can plot these points 1, 0, 2, 1, and 5, 2. So I need maybe one more tick mark right about there. And there it is, moved over to the right. So when it's x minus 1, it moved to the right. When it was x plus 4, it moved to the left. Okay.